Hello and welcome to Diana's Makerspace. Yesterday I showed the KZ80 computer, and what happens, it actually did work. It ran a program where it set the latch and it stopped. But what I did, I had an idea yesterday, was to remake it, so to make it more serviceable. So what I did, you can see what I did is I added the serviceable chip up here that could be pulled in, pulled out. And then back here, you can see, back here, let's see, just raise this up a little bit. You can see data latch address A0, A7, A8 through A15. And this is the function generator that I used to test it. And what I did is, the way I discovered that the program was doing the program was, first I ran it on fast mode, using the oscillator here, and that at 4 megahertz. And I noticed the light went on, but then what I did is I set the function generator to slow mode at 22 hertz, 22 cycles per second, to run it that way. The way I tested the program to see that basically it was doing what it was supposed to be doing on the program is, let me just move some of this stuff here and get the one coding here. Oops, come on. This is the program code, and as you can see, basically it starts at 0000. What it does, it loads the D register with the barbershop pattern of A0, and what happens, so with the barbershop pattern, that means that bit 4 is set and bit 2 is set, but basically bits 1 and 3 are off. And then the port register C is set to port 0. Then register A is loaded as a counter that goes out to 255. What happens what it does, it sets the value out to 2, it sends the value out, it decrements A, and then it sends it, if A is still above 0, it jumps back and decrements A again until it gets to 0. Then what it does, it loads the value of D to 00 to reset all the LEDs to low. Again, A is set to 255. The data is output to port 0. Then A is decremented, and then basically if A is above 0, it repeats to L2, and then the program halts. And that is what happened yesterday. The reason why I didn't realize this, I thought I had a different program. I thought I submitted a program which was a blink program, which would go on and off continuously. Now, my blink 2, the halt statement is replaced to a jump start, which is at 000, where the load A at 08 starts. So basically, when it gets done with the 2 loops, it jumps back and starts again, which I'll test on another system. And the thing that I did, though, is what I wanted to do is make this more maintainable. So basically, I put this up here like that, and I got data registers. And notice I'm using DuPont cables. I'm getting tired of broken jumper cables. But I still kept basically the reset cable and the clock cable. So when I used the function generator, let me separate these two. I used the function generator. This was the clock line, and this is the reset line. So when I did the test, I just tied the reset line to positive, and then I put a signal in. Now I'm working on a new design, which is a little bit better, and uses the same principle, same design, but sleeker. And I'll show you that in the future. But so far the program does work, and I'm going to refresh the drive with the second program. So just to finish, this is what the second program looks like. And you can see basically it's a basic program that just takes data outputs data to a latch from port 00, and this is written in Z80 code. And I prefer a listing where it has the program space and the byte space. Well, let me know what you think. And this has been Diana's Makerspace for April 17th, 2025.